Hey everyone, welcome to this live show. This is Learn the Tech, and we have show number 9 for Tuesday, March 15th, 2016. And today, how does the PC work and what it does from basically the moment you press that start button and goes into the operating system. So I'm going to check it out with this good old Pentium 4 here in its case. I've opened the case so we can have a look inside, see what a computer looks like, and how it works. So it's going to be interesting, and I hope you find that interesting today. So how does it work, and what's the typical PC doing, basically? So we're going to start checking that out for sure. So this is a good old Pentium 4. It's an example that I had, and I wanted something big like a desktop. Thing is, desktops is not something that I really own much because I've been converting to laptops, and that's why I have an old P4 to do the demonstration here. Now, first of all, one of the common misconceptions of this PC, people think that a desktop and a laptop are different. And this happens very often. I remember even in my family, my sisters and people I know telling me, oh, a friend of mine wants me to help her, but she's got a laptop. I don't know how it works. Well, the thing is, the laptop works in the same way as a desktop. It's exactly the same computer. It's just that it's in a casing that is smaller, more compact, and portable. So if you take that form factor, if you take that out, well, basically it's the same thing. A laptop and a desktop actually have the same components, have the same way of working. There's really no difference between a laptop and a desktop except for its form factor. So that's the first thing you need to know. If somebody asks you and you got a desktop, oh, can you help me with something? Don't be afraid. It's the same computer that you have at home. It's just a different look. So first of all, we'll talk a little bit about the computer itself and talk about the components and see inside the computer. So the core components, first of all, of the computer, what they are. Well, of course, you got the good old case here. This is the case. This is a good case. This is an Antec case. For this computer. Of course, every computer has a case. Even the laptop's case is that little case that you have with the keyboard on it and that clam shell type closing lid for the laptop. It's simply a different form factor. The main circuit, the most probably the primary circuit, what you really need to have your computer is this big circuit board here inside. All of that goes from the edge over here up to the edge over here, down here. That's what we call the motherboard. The motherboard is, think of it of basically being the highway system of your computer. The motherboard basically connects everything together. The motherboard will connect and make sure that data flows from one part to the other. So it contains pretty much all the basically highway system between all the parts and contains several parts. One of the main parts is this, what's called the CMOS, or the BIOS is on board. And typically the BIOS, if you look here, there's a battery, a type of little battery here, which is like a watch battery. That's the battery that actually holds the information of your BIOS, so the CMOS inside, and also the clock. If you've ever wondered why your computer keeps time even though it was unplugged from the power, simple, that little battery keeps the clock ticking. But it also keeps all the updates and all the information that you've set up in your BIOS. Removing this battery, your BIOS will reset basically to 0, and it will reset to the standard manufacturer. So motherboards, this is one motherboard for a desktop, but there's a motherboard in your laptop. It usually takes pretty much all of the inside of your laptop computer. So that is kind of the highway system. It interconnects the parts. It has all the highway system with different speeds that will send information from, say, the graphics card to the GPU to the CPU to your screen between the RAM memory and your hard drive and so on. This is pretty much the base circuit of any computer, and everything plugs on this. So basically, you could have that board, have a CPU, have a keyboard, have a power supply, a hard drive, and you'd be running a computer pretty much with RAM memory and everything. Then you've got the power supply. In this case, it's this big box here on the back. This is what powers all of the circuits of the computer. And you might notice that the power supply has a real big chunk of cables. And that's because it has to deliver several different voltage throughout your system, because each components work at different voltages. So there's a voltage for the CPU, there's a voltage for the memory and motherboard, there's a voltage for the USB ports, there's a voltage, a 12-volt voltage, and there's, each different little part needs different voltages, and that's why it's just so tangled. Instead of being just, two wires that power everything, it's typically a big connector that has all sorts of power. Now, in a laptop, your power supply is that black rectangle that's on the cable that you plug into your laptop. And typically, the different voltage is also in the computer, but the difference is your power supply has only 2 voltages. Where it's happening is in the circuitry inside your laptop. There's a special circuit that splits the voltage into different little voltages, like all of these little colored wires here that typically will power your computer. Then we have the CPU. CPU is typically hiding right here under this big fan. This is a Pentium 4, so those that have Pentium 4 might recognize this fan of an Intel Pentium 4 CPU. So underneath that is basically the brain of your computer. The CPU is that circuit that just computes everything the computer wants to do. It's without the CPU, the computer would just be a dumb electronic box doing nothing. And the CPU just crunches all that information of zeros and ones, and basically is able to display, for example, what you see on the screen right there of my Learn the Tech show on the TV. So basically, it's working hard for everything that you do. So when you power up a program, an app, even Windows, everything uses CPU time. The CPU needs to crunch information for everything to work. Now, why does it have such a big heatsink and a big fan on top of it? Simple. For all the components in your computer, the CPU is one of the components that generates the most heat. So typically, your CPU gets hot, and the more you actually have your computer working, the more it's hot, and the more this little fan starts turning up. And you know what? That's where you hear the fan. You sometimes tell me, oh, is it normal, my fan? I hear the fans all the time. There's a good chance that the one you're probably hearing is the one on the CPU. Same thing on the laptop. The laptop CPU is usually pretty close to the side because it needs to evacuate the hot air as fast as possible to the outside world. If you don't put a fan, for example, if I were to remove this fan and start a computer, not only will my computer tell me, first of all, there's a fan missing, but the CPU would probably stop the computer after barely 30 seconds. sometimes even faster. The CPU is really heat up real fast. And there's thermal paste to help dissipate all of that heat, basically, from the CPU. So the brainhead computer is under this right here, and it's connected to that highway, which is the motherboard, because that's how it gets its information, and that's how it sends out the information it needs to do so. Then we have RAM memory. What's RAM? RAM is that random access memory. It's what the computer uses while it's on. It's the fastest memory in your computer. And you see the RAM, it's right here. I can actually just go here and remove one of the RAM modules so you can see them. So typically, this is a RAM module that is in the computer. This is RAM. This is where Windows is. This is where your programs reside when you're using the computer. This is the fastest thing that your computer has. So basically, RAM memory will be used all the time. It's where all the information that you need to get real fast is stored. And that will help the computer be as fast as possible. So there's different amount of RAM memory, so different modules. In a laptop, typically, a RAM module will be about half of the size, about this size, even a little smaller. So basically, a RAM module will be much smaller. So that's RAM memory for you, and that's where everything's stored. So imagine millions and millions of little bits of data are stored in this little thing here. So that's pretty amazing when you think about it. And if you think about the fact that long time ago, we had, 512K of memory or 640, and that today we are talking about gigabytes of memory. These are 512 megabyte memory. So with two of them, that means I got 1 gigabyte of RAM. Now that's a Pentium 4, and it has Windows XP, so 1 gigabyte is more than enough in this case. But today's computer, I'll have 4 or 8 gigabytes of RAM, which is pretty amazing. Then, what's plugged in? Of course, the hard drives. Now here I took out the hard drives. Typically, the hard drive is that big box here that you see. This is a hard drive. It's inside these metal slots here because this slides into the side of the computer right here. Now, this is another hard drive that doesn't have these little slots. So this is where everything's stored. So your Windows is installed on this thing. Your files, your music, your videos, everything is on this. What does this have in particular? It has little platters that turn inside at very high speed and a little read-write head that moves and reads the data all the time in a very fast pace. And it's actually pretty impressive to see a hard drive work. Today, some newer computers, a lot of them have new types of drives, which are SSDs, which are solid-state drives. Solid-state drives is a new thing, and it is faster than the good old hard drives that I've just shown you. Laptops also have hard drives, but they are typically much smaller than this. Laptops will have very small, thin hard drives that fit into the smaller form factor of your laptop, basically. Then cooling devices, of course, we have fans. There's one here, there's one here, there's one in the power supply. And often there could be one in the front of the computer's casing. There could be one, there could be many fans. There could be some on the side. Depends on the type of computer very often. A gaming computer, for example, will often have more fans than a regular, cheaper computer, because what it does will generate more heat. Games typically will generate a lot of heat, for sure, on the computer. Another thing that it has, this computer is onboard chip, but here there's a slot here. And so computers can have, with PCI Express cards, an external display. Now, this one does not have anything in its slot, so it has and relies on an internal and onboard chip. that has video capabilities. Now, this usually means that the computer's motherboard is of a cheaper design because it doesn't necessarily need something else. But usually a gamer or somebody that really wants more will have here a card that's a graphics adapter card. You also have here the PCI slots. These are expansion slots, and there's all sorts of slots. Today, we have more PCI Express, less PCI. In the old days, there were some ISA slots. These were the good old days of 386, 486 computers. These are expansion slots. So these are empty right now, but you could put, say, a modem. You could put here all sorts of cards that do different types of work, different peripherals of all sorts. And, that will expand the capabilities of your computer, basically. Of course, there's cabling, a lot of cabling. So there's, SATA cabling. There's a regular connector for power. And there's also all the cabling for drives. Like here is an old PETA drive or IDE drive connector, and so on. These are all interconnecting all the parts from the computer all together to the motherboard for that to work. So basically, all of these things will be interconnected to have your computer working. So basically, today's computers will have all sorts of things. So you'll have integrated Ethernet ports for plugged internet. A lot of today's desktops and most laptops have Wi-Fi for, of course, internet, wireless internet. They'll have ports, USB ports of all sorts. These are also connected to the motherboard because that's where the central data, all the information is going through all of the computer. That's for sure. And, you'll, of course, use PCI, PCI-X, or PCI Express type cards to add new stuff to your computer. And that's, the interesting part. That's why a computer is just so powerful, because it is possible to expand the capabilities by adding stuff. Now, it has to say that that's why some people choose a desktop like this rather than a laptop. It is difficult on a laptop to add new capabilities because of its small form factors. Usually the manufacturer will not really add any much feature that you can expand on, and everything's pretty much closed down. So a laptop is often as is, and there's very little you can do except maybe adding RAM or changing the hard drive, for example. But on a desktop, thanks to the space and the expansion slots that there are on these boards, that's what a lot of people, a lot of tech enthusiasts like. They can add all sorts of stuff to the computer, add cards that have new capabilities, change the graphics adapters so that they can have something more powerful when they play games. They can easily change a lot of stuff. You can even easily change the motherboard in a case like this. You can just strip it out of everything, buy a motherboard, shift the motherboard with a new one, and you'll buy a new CPU, new memory, new hard drives, and basically you'll use the case for a newer type of computer that's more powerful. So that's why some tech enthusiasts will want to have a desktop. It is easier to upgrade in general. Now, when you power up your computer, when you first power up a PC, the machine goes through different stages, okay? The reason how your computer works is it has a lot of steps, and it doesn't show because, we rely on the fact that we press that power button and, I don't know, a minute later, 2 minutes later, we have our, Windows operating system on our screen. But there's a lot of stuff that's happening when you power up your computer, much more than you might think. Basically, when you power up the computer, which is called the boot process, by the way, and the boot process is short, by the way, boot. For those that wonder, boot is short for bootstrap, which is a reference to the old adage of pull yourself up by the bootstraps. It's kind of a way to say that you're going to start something from the very beginning. So that's a little piece of information that a lot of you probably don't know. So boot comes from bootstraps. The boot process is controlled by the PC BIOS. So I told you that little battery here that maintains the BIOS information and everything it needs. Well, that's the first thing that happens here. The BIOS controls the startup of the computer. It does several little things. So the BIOS is basically a piece of software that's what we call flashed or burned or programmed into a chip. And that little piece of software will, of course, decide how the computer will start up, basically. So the BIOS is always embedded in the motherboard. It's always there. Every computer has a BIOS. No computer don't have BIOSes. It's sometimes called different names, but every computer has one. You have a Mac computer, you do have a startup BIOS type software. Every device, your phone, every computer or portable device has such a startup type program. Like I said, it's not always called BIOS, but it's the same type of information. It's the same type of functionalities, basically. So what happens basically is, besides controlling the boot process, the BIOS provides a basic configuration interface for the PC's hardware components. In that interface, you can configure such things as, the order that you want to read drives. So the BIOS, you can change drive order. You can, play with settings for how fast the processor is going, how, everything is going to be basically configured for the boot up process, what type of output display you want to use, and so on. It's very, very complex and simple at the same time. And so the BIOS is, every computer's BIOS is accessible in some way, but it depends on the computer you're using. So basically, you press the power button. The power button, okay, because when your computer is plugged in, you might have noticed on some computers, there's a little light, in desktops, I hear, my clients telling me, hey, you know what, it's dark. I noticed there's a little light inside the computer. I think my computer's not shutting down. And that's the thing. Your computer, when it's plugged in and when you shut down in Windows, still has current flowing through it. On a laptop, you often see a little power light in the front because you're plugged in the wall socket for the power adapter. On the desktop, you will often see a little green light on the motherboard lighting up through the case. That's because the power is never totally shut down in a computer. It always keeps a minimum, and that prevents, for example, the CMOS or BIOS battery from draining. If your computer would shut down completely, what would happen is that the CMOS battery would eventually drain down at a faster pace than it is designed to. So, they designed these circuits thinking, well, your computer is going to be plugged in all the time. So these are little things that that can happen. Some computers don't rely too much on the battery, but others rely much more than others. So you press that power button. Yes, there's a little bit of current, but the power button, what it does, it triggers the power supply here, and it tells it, okay, turn on and give all the power to all the parts of the computer so that the computer can start up. And basically, a little signal is sent to the power supply to give it the kick necessary to just, flood the motherboard with all the voltage that it needs. Now, the motherboard gets all the current suddenly. So what happens is that the motherboard is becoming alive and will perform the first thing that any computer will do, which is called post. Post is the power on self-test. So if your computer stops at a black screen, stops at an error message at the beginning, a series of beeps, well, that's because of post. Power on self-test will basically do a scan, a program scan of everything. So it checks for hardware failures. If you have a desktop, you might notice that your desktop boots up with one beep or maybe a series of beeps, but when it boots up, it always does the same sound. That's the post basically saying, that's good, we're good to go. But the post also has a series of sequence, and the sequence of the beeps actually will tell you what's wrong with the computer. So you might have a series of beeps, and now a lot of the motherboards, unfortunately, there's no universal code sequence. It's sad because if every motherboard vendor would basically, sell you have a kind of a standard for the beeps, it would be cool. You just learn the beep charts, and you'd go there and you're like, okay, 3 small beeps, 3 big beeps. That means this. The problem is that every manufacturer has its own beep codes. So what happens if I turn on this computer and it gives me, say, 2 short beeps, 2 long beeps, 2 short beeps? I'll have to go to the manufacturer. So I'll have to check the motherboard, see, okay, who makes this motherboard? Go into the manufacturer, look at their beep codes, and okay, 2 short, 2 long, 2 short means no video. Oh, then the video chip or video adapter might be broken. 3, 4, 5 long beeps. Oh, there's no RAM memory modules, or they're defective, or they're not plugged in right. So this is the first thing. The post will tell you what's wrong with this computer or any computer. And you know what? Even laptops have beep codes. So your laptop, if you remove the RAM memory, you'll notice it has beeps. A laptop is more quiet than a desktop very often. When it boots up, it doesn't beep. But it doesn't mean that it doesn't have the beeper. All the computers do. So that little beeper is there, and it's there even in a laptop computer. So if everything is all right, you'll get the regular standard beep. Often is only 1 beep. Some computers, depending on the config, will have 2 or 3 beeps. And it continues on. If it did find some kind of problem in the check process, then there could be a number of beeps. Now, one of the things that you need to know is not all computers necessarily will report you a problem. The beeps that it gives you is there for a certain number of problems, but it might not beep also. For example, if some of the motherboard is dead for some reason, it might not beep at all. You just have to test it and see what's wrong. Some other type of failure, like external failures, hard drive failure, for example, might not beep at all, because these are not the things that the motherboard will, typically give you a beep or be able to detect. So if everything is okay, now what happens is that basically after the post, first, if there's a failure with a certain number of beeps, very often it doesn't display anything, and some types of beeps, it will display information on your monitor. Once it's past the post, once it's done its self-test, and it says, well, everything looks all right, everything looks like I want it to look, so I guess we'll start booting up. Well, that's where you see the first information. Your PC will display information on the attached monitor. If it's a laptop, of course, the monitor is that computer screen on your laptop. So you'll have BIOS manufacturer sometimes in revision, processor. Sometimes you have processor specs, amount of RAM installed, and drives detected. But you know what? Many PCs have replaced this display of information with a splash screen that shows simply the manufacturer's logo. So, you know, you won't have any info, but you'll have Dell or HP or Lenovo or Toshiba, and that's all you'll see. But you know what? That screen that has all the information is still available, and sometimes you can go into BIOS and have it boot up with that information instead of displaying Toshiba, for example, or Dell logo. You know, I always like to see that splash screen because it gives you lots of information and you have a visual of everything that's going right or not. And unfortunately, more and more, it's a logo. So what happens when that happens? Well, basically, that info is showed up on your screen, and the BIOS will attempt to access the first sector of the hard drive or the drive that's designated as the boot disk. So the first sector is the first kilobyte of the disk in sequence. If the drive is read sequentially, starting with the first available storage address, the boot disk is typically the same hard disk or the solid state drive that contains your operating system. So basically, it's going to go on the hard drive here. It's going to look at the first sector and it's going to say, okay, let's see here. What's here? So basically, it looks there and it confirms there's a bootstrap loader or a bootloader. And that is what's on here. So if you're on a Windows PC, there's a bootloader sector. And what it does is simply checks the first sector of the boot disk and it loads that bootloader into the RAM memory of your computer. The bootloader is again a small program that's designed to launch the PC operating system. So you see all the complex process. We're not even started yet, but we already had all sorts of checkings and all sorts of self-test, and you have another check for a little program that's the bootloader that's loaded into RAM. Once the bootloader is in memory, what it does is the BIOS hands over its work to the bootloader. So now the BIOS, is on its own. Basically, it's left and it will do only most of its basic tasks of controlling what's happening on the motherboard. And computer itself is actually going into another control sequence here. So basically, the bootloader will look at, okay, it seems there's a Windows operating system here. It should be at this position on the hard drive. Let's take a look. And if your hard drives are right, that's what's going to happen. It's going to start loading the operating system. So the bootloader, when it finishes its task, it turns control of the PC over to the operating system. So that's really the operating system starting after the bootloader that is really going to take all the control of everything in the computer, or almost. So basically, control is sent to the operating system, and the operating system starts doing what it needs to do. It has its own sequence of initialization also. The operating system, of course, itself will try to initialize different parts of your computer, different hardware. And so every computer has an operating system. It's the only way that you can use a computer. It needs to have such a device, such a piece of program. Some computers might have it in a chip. That's why your smartphone starts up. It doesn't have a hard drive, but it has the operating system on a chip inside the device, so it can start up. So after PC boots, you can control it through an operating system, or what sometimes you might see as an OS, which is an operating system. And so your PC can be into Linux, it can be into Mac OS X, it can be basically into Windows. depending on what you use your computer for. So what does the operating system do also? It has several tasks, the operating system. So when you're in Windows, basically, in the Windows operating system, you'll have the processor management. So the operating system will break down the processor's work into manageable chunks and prioritize them before sending them to the central processing unit. So, Windows looks like, wow, it's there to just help me do something, but it does an amazing job in the background. It does a lot of little tasks in the background, tasks that you don't really see much, but they are there, and they are very complex. We often say, well, look, I'm going to the start menu and doing stuff. How can this, operating system go so bad? Well, with all the tasks that it has to do, and the fact that the computer needs to have the parts working correctly, all of that needs to synchronize and work well together, and that's a complex issue. Another thing that the operating system does is memory management. It coordinates the flow of data in and out of RAM. It determines when to use virtual memory on the hard disk to supplement an insufficient amount of RAM. So basically, it checks because it needs space. It needs to work. I've told you that the programs go into this little thing, which is a RAM memory card. Well, basically, you need to have sufficient RAM. And what it does, the operating system, it looks at RAM and it says, okay, we've got this amount. We can do and send all this information into the RAM memory. So, if we look here in the task manager, you have a visual of that here in the task manager. Let's check out the performance and look at memory. Here it goes. Here you've got the memory and performance. This is the information of the memory on the computer on the screen. And this is Windows actually working out, checking out how much RAM it needs to use. And if it doesn't have enough, what it's going to do, it's going to say, well, I don't have enough RAM for all the programs. So let's use a page file. Let's create a big chunk of disk space where I'm going to put everything that doesn't fit into RAM there. And that, if it happens, well, it usually does happen, and all computers have a page file as some sort of windows of information written on the disk. But if that is because you have not enough RAM memory, now the problem that happens is that your computer starts getting slow. Why? Because a hard disk like this is extremely slow compared to RAM memory. That's why a computer has RAM. It's the fastest thing that it has to write and read information. So if a computer slows down, sometimes it's because lack of memory. And that means your hard drive is working much harder, slowing down everything. What else does the operating system do? The operating system has device management. And you can see it in Windows in what's called the device manager. The device manager is another part of the operating system. So if we look at device manager, what it does is give us a list of all the devices in your computer. So device management provides a software-based interface between the computer's internal components and each device connected to the computer. So it includes interpreting keyboard and mouse input or adjusting graphics data to the right screen resolution, network interface. It includes managing your internet connection into the device management bucket. So basically, it has to work with all of these devices. And that's another place where things go wrong in Windows. These devices are controlled by programs. That's why when you say I click display adapter here, it says Intel HD graphics, but when I click, there's something called a driver. What's a driver? Simple. A driver is a piece of software that is in the middle between the part. So here, the display driver is a chip that's on board the computer. The driver is the program that tells Windows, hey, this graphics adapter to display information correctly works like this. And that little piece of software can have bugs. So sometimes you'll say, man, Windows is just so buggy, it's just so bad. And the problem isn't Windows. It's the manufacturer that makes that part just wrote a bad piece of code in the drivers. So, it's important to understand that more than 50% of problems in Windows are not even Windows related and are not even the fault of Windows. They're the fault of other manufacturers doing bad things and making Windows crash. One of the things that you got to remember also, and that's something that people never really think about, but when somebody tells me, oh, my Mac doesn't crash as often as my Windows machine, you got to understand that the Mac computer and the operating system are made by the same company. Apple makes the software and the hardware. Of course, they can tweak it and test it like crazy to have it working right. Remember that Windows is just a piece of software. A piece of software that needs to adapt to 1,000,000 and 1,000,000,000 different combinations of hardware. So every computer is different, and Windows needs to adapt to that. So when you start thinking about it, Windows is actually a pretty amazing piece of software because of the adaptability of Windows to pretty much everything that's happening. Unfortunately, because of bad drivers, because of bad software, well, Windows sometimes has a hard time making everything work right. So that's, the bad side of Windows. And often, Microsoft and Windows take the bad reputation off of that, when often it's not really Microsoft or Windows' fault. So that's something that, people often misunderstand in computers. So what does it do also? What does the operating system do also? Well, it also has storage management. So it directs all the data where it needs to be. So it could be on a hard drive, a solid state drive, could be a USB hard drive or thumb drive, sending information to RAM. It needs to find storage and, create these tasks of not only reading and saving information, but editing, moving, copying, deleting documents. All of that is done by Windows. Windows manages the storage. So you see another task that Windows is doing, and it has to do what you want also. So imagine you're playing a computer game. It's doing 1,000,000 tasks to have that working. And as you're playing a computer game, it manages the storage of RAM. It manages your hard drive for saving data of your game. It manages, the process of the CPU and everything that it needs to send it for everything to work right. So it's a very, very important piece of software, and it does a lot of things that we don't even think about as we're just, watching a YouTube video. Now you're watching me live now. And what I'm saying right now is that your computer is doing all of that at the same time that you're actually watching this live show. Pretty amazing when you think about it, how just great your computer is and how great Windows is actually to make all of that happen. That's pretty cool. And of course, Windows has an application interface, provides data exchange between the software programs in the PC. Another task. So you're watching this YouTube show live. Well, your computer is also having your browser communicate with the CPU and the different parts of your computer for everything to work and all the information to be displayed, for that video image to be right there in front of you, sending information and bits of data to the graphics adapter, saying, hey, here's what you got to display for everything to work right. It's pretty amazing. So an application must be programmed to work with the application interface for the operating system. So that's why a program is made for an operating system specifically. It needs to be able to interface between the Windows operating system in this case and the software itself that wants to do something. So that's pretty amazing. And that's also why you see, well, this is, good for Windows 7 or 8 or 10, but not in Windows XP, or because it's very specific. The programming code is extremely specific to what operating system you have. Each Windows version is different. It has a different way of doing certain things. Some of the core stuff is still the same. There are things in Windows 10 that are exactly the same as Windows 95. There are a lot of things in Windows 10 that are brand new, and you just need a new piece of code to actually access that. So that's why you have, this works with this or that operating system. And finally, what it gives you is a UI. What's a UI? A user interface. A way to interact with you. So, it's got this nice start menu. It's got these icons, and, it's got this desktop. So if you want to, work, you got to have this desktop and everything. And it interacts with my keyboard and my mouse. It does everything. So it needs not only to do everything that I just mentioned, but also maintain a type of interface that a human being can use if possible. So that's also part of the operating system. That's for sure. So pretty amazing when you think about it. Now, if we think about it, what about the future? What will be the future of all of that? Now we're getting into, we're still using basically the same good old interface and the same good old way of working with PCs that we did 20 years ago, even 30 years ago. Oh, it's more modern. In the 80s, my first PC ran DOS, which was a form of an operating system, basically. And it enabled, commands to be sent and do a certain job. But programs back then were much more core-oriented. They were using the CPU stuff directly. They were, talking more directly to the parts that they needed to work. Where here in Windows, what's changed is the program now needs to ask Windows to do tasks, which of course simplifies the program code also. It can also bypass that. Games often bypass certain things in Windows because it just makes it faster. But it will also use certain other options in Windows, like DirectX drivers, for displaying correctly the information on the graphics adapter. So typically, we're going into the future now, but the core thing of any PC is that the way it still works is the same. Any type of computing device you see has all of these checks, has the self-tests at the beginning before it loads some kind of operating system, and that operating system will interact with the machine and do certain things. Every machine works pretty much in the same way. And I would say that probably, what might change in the future is that core thing of how computers work, basically. The form factor of everything is changing. We're passing from desktops and laptops. More and more people are using, tablet computers and smartphones. That's why the PC market is actually dropping. Why is it dropping? Because of the passage from the, you know, world of personal computing into something that's much different. One of the funny things of also our future of computing that I find really, really interesting is the fact that the system, the power of the devices we use is actually less and less powerful, and it's more and less powerful. And what I mean by that is, look at today's laptop computer, like a Core i5 machine, which is a very powerful device. Yet, there's a way of now using technology that requires less power. So we get these iPads and these smartphones that are very powerful, but not as powerful as a PC, say. But they can do pretty much everything they want. Part of that is also thanks to how efficient programming is. I mean, one of the things that I think we lost in a certain way is that basically the operating system itself. I just lost my thought here. I was looking at an email. So basically, the processes are we're talking about more efficient stuff. So the code is written in a way that makes it very, very efficient to the same job. One of the core things that lost Windows, and that's what I wanted to say, is when these computers became powerful and all that RAM existed and all that the possibilities started existing, one of the major problems that happened is that people became kind of sloppy in programming, and they just wrote bad code to do something and used a lot of RAM to do some stuff. And you know what? That made for some really bloated and way too big piece of software. One of the things about Windows 10 that's interesting is that they've kind of come back to that. Let's do a sleek code. Let's do something that's efficient. Let's do something that's really, fast and that will require the least of all sorts of, RAM memory, disk space, power. And, we're getting into a time where we're not really necessarily getting devices that are much, much more powerful, but we're getting devices that are more efficient at doing a job. So even though they are powerful, they are not necessarily as powerful as they could have been if we would continue on that track of getting power and power and power all the time. But we are still going through that. I mean, with the future, having computers interact more humanly. So having computers that can talk to us, having computers that will understand our language and understand much more what a human interaction is. Of course, we will need more and more power for all of that. So basically, that was a quick tour of a PC and how it works basically in a very, of course, simple way, but it's pretty amazing. And when you think about all the electronics in there, I mean, you can see that there's basically, billions and billions of transistors, and all of that works together. It's just amazing when you think about it. It's just so amazing that it's just a wonder of how we can do it. And all these little robot factories that basically make all of that hardware work on computers. So I hope you enjoyed this quick, but I hope for you interesting look at how a computer starts, at how a computer works, the different parts of the computer. This, of course, is part of shows that you decide the subject. So if you have a subject for this show, please, you can leave a comment below the video. You can also send an email at helpwithyourcomputers@gmail.com. And of course, we will have different subjects. It's always a subject selected by the viewer. So I hope you enjoy that. Next week, we're having a subject still in computers. And several people asked me that. So what different processors, all sorts of different CPUs, what they're all about, Intel, AMD, all of that. What is that? What's the CPU? What does it do? And the different types of CPU we have available and how they are used. We'll have a little history of the CPU also. We'll go back in time to the first one and how everything evolved with time also in the CPU market. We'll look at today's CPUs also, the different ones from Intel and AMD, and because it's one of the things that people don't understand a lot. What's the difference between this and that? And there's little differences here and there. So I hope you're gonna have as interesting show as we can. And of course, don't forget, you are the one that will decide our shows. That's for sure. Always send your subjects. It's super cool to do this show. I hope you enjoy Learn the Tech. See you next week. Learn the Tech is every Tuesdays, 6 p.m., 2200 hours Universal Time. Take care, everyone. Have a nice week, and see you next week for our shows once again on this Windows channel. Bye-bye.